So, hello everybody. Thanks for showing up so late in the evening. I'm stunned and I'm it's crazy. You're all awake? You still can make it? Need some more coffee? Well, thanks for showing up. So, we're going to talk about serialization protocols in Scala today. And first of all, like what I always like to do is present in a talk is the why. And even before that I'd like to talk a bit about how I came to this talk, because it was a once in a lifetime unicorn event that I used to work as a consultant for Codecentric, working on a customer project, and we were in a situation to decide which serialization protocol to use. And the once in a lifetime event was we had time to research. We had time to think about that. And yeah, we wrote something together, made like nice little wiki pages, and I thought, well, the results of the research we did was kind of useful for everybody else, so I made this talk out of that. And now for the reasoning, why would you bother? Why would you bother with serialization protocols? I would say the most important aspect that we have right now is that system designs is changing. If you have been to meetups kind of like 3 years before, 2 years before, microservices was all the rage, right? Everybody was talking about how to do microservices, how to build them. And yeah, suddenly these little things are now mainstream. You see them everywhere. Everyone does microservices or already monoliths again, and or just step that step and kept their monolith. But yeah, they show up everywhere. And even after that, queues are showing up in these microservices architecture too. Not everybody is doing direct synchronous REST calls, but some people are using queues to communicate. Some people abuse distributed logs as queues and still use that. And I think just 1 year ago, I was still listening to all these bank talks about giving us the bank account example for CQRS and event sourcing. And now even these show up in system designs. And finally, hopefully, we're not using databases as integration layers anymore. So you do? I'll find you. I'll poke you if you do. So that brings us to some pretty fundamental changes in how we are designing systems. And I like that tweet from Tim Parrott very much, where he said that distributed systems are about protocols, not about implementations. Because if you look at the distribution of complexity or the overall issues that you have, or just the amount of pain that you feel when building these systems, then it's mostly about the communication between the little pieces and not about how to implement a RESTful API service in play with HTTP or so. That kind of always works the same. But to wire these parts together suddenly gets very crazy. And also, just recently, I read a book from Rebecca Parsons and from Neil Ford and Patrick Kua about evolutionary architectures. And they don't talk much about serialization, but they talk a lot about building evolutionary architectures, architectures that adapt themselves to change, and architectures that have change as a core competence or as a core principle in their design. So yeah, other people are picking up on that too. They're writing books about it. And since I keep using that word, I make up my own definition because I didn't find anyone who had a good one. If you find one, please send it to me. I will proclaim that evolvability means the ability of a system and its data to adapt to change. And that's going to be the working definition that we have here for the scope of this talk. And if you remember the very bad old times that we had when we were working on very big monolithic systems and very big, very expensive databases from a company with a big O, and we were doing our migrations, and we were changing something, yeah, we had to do a schema migration of the database, which would usually anger the DBAs, and we would do our code changes. And in the end, we would do one very big deployment, which was planned for weeks, and it would fail, and it was all very horrible. But that's not the case anymore. We cannot afford to be that slow, and our systems do not work that way anymore, because we now have, as I told before, we have replicated systems, or not just distributed, but replicated systems. That's kind of the the easiest case of the problem, right? You have not just one instance of your monolith, you want to have maybe 3 instances, and maybe they need to communicate between each other. Or you have distributed systems in your data center, or maybe you're even doing serverless because it's all the rage and you've been to an AWS keynote. And now some very fun thing that I keep struggling with, or I keep messing up, is even distributing some things to the user, which means a fat client or even sessions stored, and anything you push out to the user or your clients kind of makes it distributed a bit. And one of my famous mistakes that I keep doing is, if you have any kind of web application and you have any sort of authentication, authorization system, what do? You have some sort of user class that you store in a cookie. And what happens? You change the user, so your cookie doesn't match, and you back and forth, and suddenly users cannot log in anymore. Logged in users cannot access anything anymore. So that keeps happening to me. And so therefore, I would say there's more distribution in your system that you might even be aware of. And yeah, these systems, they exchange information all the time, right? And that is problematic because these systems are also changing all the time. And one more final thing to finalize some words that we have is, in our community we like to invent a lot of words, and one of them, and usually we like to invent words for things we already have a concept for. And here it's encoded, serialized, and marshaled, and its counterpart of decoded, deserialized, and unmarshaled. Depending on which glasses you have on or which goggles you have on, it kind of always means the same. And for the sake of this talk, I'm going to go with serialized and deserialized. And I mean all the other things by that as well. So yeah, we got problems. I think we understood that now. And the question is, well, how can we deal with this? The first one, which usually comes to mind if you're having any kind of programming language, is, be it Scala, be it Java, be it Python, they all have something programming language provided. So we have Scala serializable, Python has its thing, Java of course has its thing, which Scala serializable builds up on. So we could technically use it. If you only take one thing home from this talk, then do not use it. And I will be talking at great length advising you not to use any of the default serializers provided in your programming language, because it makes your car burn. It makes for a horrible sorts of mistakes. So, well, let's start with the obvious but not so important bad ones. The first one is, if you use Scala serializable, you're bound to Scala. Only Scala code can access data that has been serialized by Scala. And that's a bit boring if you're in a more distributed environment where maybe other people, these crazy guys with beards and they doing Node.js and such, you probably want to talk to them even if you don't want to. So think about them. The second issue is that the performance is just awful. It was never meant as something really speedy. Even though there were a couple of performance enhancements in the JDK along the time, it's really annoying. And beyond that, it has a couple of very, very serious drawbacks. And the first one is, against me standing on the shoulders of giants, quoting Joshua Bloch and his book Effective Java, that you really should have read, like completely. And he says you should be very cautious about implementing serializable. So if you don't trust me, trust this guy. He knows what he's talking about. And because, well, once you have released something and your software is released and it starts serializing things, it's really, really hard to change things afterwards, right? Because what the Java or the Scala, the Java serializer does is just throw the binary directly at it, and then the JVM tries to make some sense out of it. And that has the effect, which I really like that reasoning, is that the implementation of your class, the inner structure of your class, your most inner fundamental secrets that you want to keep hidden in the from from your separation of concerns principle, everything becomes the API, because everything is out there and you have to communicate with everybody out there. And suddenly the laws of how you deal with APIs, which mostly means do not change them, applies to your inner classes, which is a really bad thing. And since the JDK is pretty naive about parsing the things it gets from serialized values, means you can dump all sorts of that, and it's crazy what you can do to your JVM and how you can execute code by just sneaking it in via the serializer. So it's really, really crazy. And yeah, of course, if you're serializing data to disk and that is now your new API, guess what? You have to test it. And so you have to test a lot of things suddenly if you want to make sure that your software is still correct. And another giant that I'm standing on, Mario Fuchsko, made at Devox a poll about which features are the most hated. And guess what? Serialization is number one. Because I would say after null, it's the second billion-dollar mistake of the JVM. And yeah, of course, I'm a very naive person. So I make a lot of issues and a lot of problems all the time. So I had issues with Akka remoting. I had issues with Akka cluster because they both also default to Java serialization. It has not bitten me personally, but with Spark, that's also using Java serialization to communicate. If you get a hold of Holden Krakow, who's running around here at the conference, I guess tomorrow, then she has a good talk about that. And yeah, what I mentioned previously, user sessions with Spring Boot. Yeah. Also Java serialization, also problems, also locking out users, also causing all kinds of horrible bugs. So I hope you believe me that it's a really bad idea. And one note about performance, because I said, yeah, performance of the serializer is awful. It is. And if you just roughly skim over the numbers, it's not so much important how they are. They're mostly on par. They're mostly kind of the same magnitude, except for the default JVM serialization. So they're roughly the same, except for our odd one, which is called default. So for the scope of this talk, I guess you won't be building the next WhatsApp tomorrow, but just a regular thing with like hundreds of thousands of users. And in scope of that, you can treat them performance-wise as equal. The four things I'm going to present to you later. Right? If you need it really faster, if you're building the next WhatsApp or the next high-frequency trading platform, you have to do a bit of more of research, because then this talk will not be enough for you. But so judge for yourself about how much you want to believe me there. And again, just please don't use the built-in serializer. Please, I beg you. And now, of course, if you're smart, you know about these things called JSON, or these, if you want to party like it's 96, use XML. These things are widespread, and I had colleagues in my career who really enjoyed XML because they claimed it was human readable. And I questioned their humanity afterwards, but they like to read it. So that would also be, after the default serializer, an interesting candidate to serialize things to. And the problem is they're still kind of slow depending on the benchmark you do. Like some say it's fast, some say it's slow. And well, they are verbose. That's what probably usually people mean by human readable. And number handling in JSON, because it belongs from the JavaScript ecosystem. So number handling is fundamentally broken and will never ever be fixed. And a character encoding is also kind of difficult. Like, say goodbye to U2F8 and full compatibility if you wanna go that path. And also, you don't have any kind of schemas, which can be a good thing, can be a bad thing, but for bigger, more complex applications, and since this is a Scala conference where everybody likes types, I think people also like schemas. instead of unschemat stuff. So I'm not going too deep into detail for around JSON and XML, and I'm not going to be talking about BSON, JSON schema, and XSD and all these friends of that ecosystem, because in the most important thing is schema evolvability, which all of them lack, and this is going to be one of the main features of the next candidates that we will see. So what do I mean by that, schema evolvability? Like, if you just think that you have kind of, it's one of the apps I'm caring about at the moment. It's replicated, but actually it doesn't have any load like most of our applications. So we only replicate it 3 times because that's like the minimum number of replication. But yeah, you want to deploy it all the time, right? You change code, you have your continuous delivery pipeline set up perfectly, so your versions just go out. But maybe you have some sort of message queue in the middle, and then you have all kinds of messages from different versions up in that message queue. Like, see, there's still some version 1 running. There had been a version 0.9, and now you just deployed your version 2.0, and they are all running, and they're all talking, and they're all dumping their data onto the message queue. And well, that's kind of a mess because their 0.9 and 2.0 are probably very different. So we can split the problem in 2 halves. One of them is backwards compatibility, where we say you deploy a new version, and that new version survives reading older data. That, if you think about naively, it's doable because you know what the old data was, so you can do all sorts of hacks and handles and do some compatibility layer yourself just to deal with if old do this, if new do that. That's doable, it's annoying, it's painful, but you can survive that. But on the other hand, what's about forwards compatibility? If you look at that extremely important architecture diagram here, you see the old one is still running, right? It should also still survive reading the new messages. So, but how could you? Because the old application can never know about the new application. I'm usually very bad at predicting the future. So this is kind of a hard problem to solve. And this is exactly where protocols come into play, because they can solve exactly this issue for us. And first one of our friends that we're going to look at is Protobuf. Protobuf is, like, great definition. It's a language neutral, platform neutral, extensible mechanism, XML, but faster, smaller, and simpler. It's from Google. They build it. They do the specification. And luckily for us, because Google likes to invent things and dump things and abandon things and invent them again, dump them again, this time they cannot, because they use it as a foundation for G-Cloud. So they're stuck with it, and which is nice for us because we have a very stable thing in our hands here. And in addition to just the specification, they also provide Scala PB, which is a Protobuf buffer compiler. It's plugin for our Scala compiler, and it will generate us very nice case classes. So we just specify the protocol, and we get the classes for free. And parsers, serializers, everything we will get for free. And if we look at, just take a peek at how that could look. If we define our data structure that we want to exchange, I started with a person. We see that we define a syntax, proto3. We'll get to it a bit later. We can define which package it will end up in the code generation. And we can define the message itself with its fields, its data types. And what is interesting is you see a number, because Protobuf has a concept of ordering their data fields. And if you want to not use something anymore, then that number is essentially burned, and you probably want to. So if you don't care about the user ID anymore, you should not reuse it, but you should continue with 4. That's and if you, I'm showing you Proto3, which is fundamental or a bit different from Proto2, because in Proto2 they still had the idea of some things being optional and some things being mandatory. And that led to tons of bugs in Google code. And at some point, they discouraged it internally and said, well, just deal with the fact that you never know what you're going to get. And so they made everything optional by default and removed the notation of requiring anything. So, and that caused big outrage, and Hacker News was very angry. But still, they made it, they released it. And that's where we are now. And I kind of like the idea that if you're exchanging messages, you cannot really require some things to be there, because it kind of it leads you down to a rabbit hole of then in the end requiring everything and writing a lot of, if this is not present, then what then? And you'll write a lot of glue and boilerplate code. And now if we look at that in code, how a nice little test would look like. I've used the same proto file that we have seen on the slides, and that generates us a nice class called person that has beautiful a builder pattern where I can add things. And I added a new field, the favorite conference, which is of course Scala Days. And I have nice methods, or I don't even need any methods because I can just write and read stream based with our default mechanisms. And in the end, I read the file again, and woohoo, suddenly my stuff still makes sense. And we're also going to be talking a bit about evolution, because I have, please go away. IntelliJ is acting up a bit. I have the same thing serialized twice. One time without the favorite conference field. That's what you've seen on the slide. And a second time I added a field, because that's what you do. You add fields to your protocol definition, and then I serialized it again. So I can read, and with my current state of the applications, I can read both. And of course, for the favorite conference of the old file is just empty. The default for primitive types or strings are kind of the defaults you would expect to be. And now if we look at what happens on disk, that's where it gets especially interesting, is that are the bytes that we have on disk. And if you look at them carefully, it's actually not too scary. I cannot make the lower thing any bigger for you, which is sad. But here you see 5 bytes, which tell you the ID that we've seen before in the protocol. Like this is field number 2, and it's of type 2, which means string. So the first byte tells you which ID it is and which type it is. The second byte tells you how many bytes of payload are coming, in this case 9 characters. And then, surprisingly well working, my first name has 9 characters. There they are. And then it just, without any further thing in between, it just starts, because the length has run out. It starts again with now field number 3. It's also a string, so type number 2. In binary encoding, and then byte encoded, it's a length of 3. And ta-da, last 3 characters of my name. So that's actually a pretty forward way. And so don't be scared about the on-disk formats. They're pretty straightforward and reasonable. So I'm going to put it on slides one more. We have the field tag, the type, the value, the length, and then the actual payload. So just to show, just to recap, we have no presence logic in Proto 3, which angers some people, and some people like it very much. All things are optional, and we have some fun little additions. Yeah, well, what I told before. So optional is now redundant, and everything is to be treated as optional. So much for Protobuf. And next candidate we have is Thrift. Thrift is a bit more than just a serialization framework. It wants to be a whole RPC framework and a whole ecosystem, a definition language, a communication protocol, so much more. And if you see that, well, Facebook developed it, and they wanted to build something really, really big, like a real, very much opinionated framework. And then, well, they developed it, they dropped it, And then Twitter picked up, and then after a while they reopen sourced it as a Facebook Thrift because they started again. And I'm just going to be talking about the real original Thrift, not the Facebook Thrift. And Twitter picked up, and they supplied us with Scrooge, with this SPT and Scala integration. That's working fantastically. If we check our person in Thrift, what I found out thanks to Mookie, who's using it, you can also set different namespaces for different languages here, and you see that the definition of the data is kind of the same like it used to be in Protobuf. They are very similar in their behavior, but with the big but of they kept the semantics of optional and required. So pick your poison, pick where you want to go. That's where they differ the most fundamentally here. And if you look at the generated code, they have you don't get a builder pattern, but instead you get a nice constructor. That's the difference. And you see here that it's also a bit leaking that Thrift is not just a protocol, it's a protocol family, it's a big framework. So you have different protocol factories, and it goes down, it goes above the scope of this talk. And here we're working with a binary protocol, which is a bit more noisy. And they provide us with their own implementations of buffers and encodings. So how we can you can download the code is on GitHub afterwards, so don't focus too much on the details. You can check it out later or just copy and paste it if you need to. It's kind of similar how you can read and write files to disk or wherever you want to. And now if we look at what happens binary. Oh, I forgot one thing. That's just here. I'm sorry about that. That's just the difference of the Protobuf without the old version, and on the right you see the Protobuf of the new version, which means if you add a field, it just puts it up at the end, and it's very easy, very straightforward how these things behave. But going back to Thrift, you see it's a bit longer. It's their binary protocol, and if we look at the slides, they have kind of the same thing. What they do, they have types, they have a field tag, so which is the ID of where it is in the stream. They have a length, and if you see about how long the length field is, they're kind of estimating a bit longer messages. Like Thrift is, Protobuf is more meant to be more rapid, small kind of thing communication, and Thrift thinks a bit more about longer messages. As you see it kind of leaks from that length field. But in the end, you still see the exact same bytes of my name encoded, and you see the type, the field tag, the length. It's just organized a bit differently, but you see very, very big similarities. So wrapping up, it's a whole RPC framework, and you can embrace that if you go with the whole Twitter stack. Then you're not only doing Thrift, but you can do the whole RPC framework, or you can just use Thrift alone and do whatever you want with it. It's kind of easy to plug and play. And well, what you need to know is the Scala ecosystem is only relying on Twitter. So if they stop doing it, then this means halfway death of the project. But of course, except for the optional and required thing, they are really, really similar. So, and then we have a bit more different friend of us here, Avro. If you have heard about this, it's also a serialization protocol, but it's really different. It started as a sub-project of Hadoop, because Thrift, even though it was a bit more focused on length, it was still a bad fit for Hadoop, because what's Hadoop doing? It's not sending messages around, it's serializing gigabytes of files of all kinds of stuff on disk, and then working on these gigabytes, terabytes of files and processing them, right? They started the whole big data craze and hype. And well, it became an Apache project, and Confluent, the people who also do Kafka, are now a large influencer, and they kind of push the project forward. And they have two different schema languages, one for humans, one for machines, which is nice. If you remember the colleague I've told you at the beginning who was very much in love with XML, he might also like this one. And they also got some nice compatibility with JSON. So if that is one of your things, then you could also use the JSON protocol family from Thrift or the direct mapping in Avro if you, for some unbeknownst reason to me, have to deal with JSON. But so far so good. They have a very different attitude to how they do it because they think so much about big files and not so much about little and a lot of files or a lot of messages. They came up with the concept of a reader and a writer schema to do the evolution, and that means that every message also carries the schema it was written in. And with that, everybody else who knows roughly about that kind of thing can decode the message. And so you need less type information in the definition because everything will be just down in the payload. And you can skip the field IDs because you have the schema with you again. So you don't have to puzzle it back like Protobuf does or Thrift does, but instead you can just read the whole files. And you will see it then when you see the serialized thing. The schema itself, it's kind of comparable. We have also namespaces. They call it a record. They have types like strings or a union between null and the long, which makes it optional. So that's still comparable, but if we look or remember our on-disk formats, this is Avro. This is what it does. And if you kind of roughly skip around what it does, in the end, you see the same bytes that I've shown you before, which is my name. But before that, there's the whole protocol already packed into the message. So whoever comes along can read it without ever talking to anybody else, which is, I guess, if you're a big data file system, a very nice thing to do because everybody can read it. But if you have a lot of tiny little messages, then you probably don't want to do it. So decide for yourself when it's appropriate. So, and since I told you it's writers and reader schemas, they just need to be compatible, because if you can also supply your own reader schema, and there's some resolution rules in Avro that allow you to do that. So now, how does data and schema find together? I've showed you the very first and basic implementation is you just wrangle the whole schema always in your payload, which might be a serious overhead for small files, or it might not matter for big files. What I've seen from Confluence, what they also recommend, if you're annoyed by that, is that you can versionize it, store it yourself, join it later, which means you have to take the message, rip out the schema, and replace it with an identifier, and at read time, take the identifier and put the schema back in, which you have to do manually. And could store it in a database, or you could use the schema registry from Confluent that will help you do that. So, and the benefits are definitely, we have support for dynamically generated schemas, and if your schemas are varying very, very wildly and just everybody can dump data into a file system, then it might be a good thing. And it operates very well with dynamically typed languages and not statically typed languages, but we don't care about them because it's Scala conference and types are all we think about. And yeah, the downsides are definitely we have the protocol overhead or the runtime dependency to get the schema in any way. And we somehow need to verify that if we change the schema, then we have to find out if this is really appropriate. Okay, so much for Avro. And fourth one of the bunch is Cryo or Cryo. I have no idea how to pronounce it. It's a bit odd because it's not a serialization framework like the three before. They were. It's more an object graph serialization that does not have a schema. It's very good at serializing big object graphs or really, really complex objects into a thing and sending them to somebody else who speaks Cryo and can unwrap it. So I would say for inter-JVM communication, for something really where performance matters and you don't have historical data and only very things stay the same, then it might be a good candidate. There's nice implementations for Akka cluster, for example. But we've been at one project where we did it to store these files in Kafka, which was bad as it is, but also trying to read them with new versions was a mess. Like, stupid idea. Don't do that, really. Again, Twitter is helping us with Chill that provides SPT integration of Cryo. And if we look at the code, looks kind of the same like before. A bit boilerplatey to serialize it, and a bit less boilerplatey to unserialize it, or to deserialize it, but still very handleable. And again, don't focus too much on the code. It's all on GitHub, and you can check it out later. Just giving you a rough overview about how it could look like, and just telling you it's neither of them are bad, and don't fear it if you. Please don't use Java serialization. Please, it's so easy. Please. All right. I lost my slides. Oh no, they're here. So now, nice about Cryo is it's even more compact. So it's really maximum dense. If we look at the whole file that I have on disk here, this is Cryo. It's 16 bytes, my message, and that was Thrift, which is 32 bytes, and Protobuf was somewhere in the middle, and Avro is just out. So if you care about the last bit, then Cryo might be for you. No, but what you really have to keep in mind, in that case, there is no schema, which is why I didn't show you a schema. So therefore, there's also no schema evolution. If the messages don't fit, it will just crash your JVM. So good luck. And then one thing I will just skip over, that because it doesn't really fit in, but I wanted to mention it. There's the thing called simple binary encoding from it's in high frequency optimized serialization from the Real Logic company from London. They're doing high frequency trading. It's incredibly fast. It doesn't support Scala, and it's incredibly complicated. So if you want to squeeze out the last millisecond or nanosecond of performance, go there, but don't talk to me. So yeah, they support schema evolution, and they do support schema evolution, but no good Scala integration, and it's definitely not so easy to use it. So to wrap it up, I try to wrap it up with smileys and make it a bit more digestible. So Protobuf is very good on the integration wise. It has concept that I personally like very much, and it fits kind of what I think when I think about distributed systems. But the version change between 2 and 3 and the incompatibilities. Have you heard about any other thing having kind of crazy changes between 2 and 3 and people don't like that? It's not going to be this bad, I promise. Well, Thrift shares the concepts, so that's why I like it. It's a way bigger framework, so be sure if you want to handle such a big framework. And the integration, I mean, the smiley is a bit too angry. It's not as good integrated as Protobuf, I feel, but it's still usable way enough. And well, Avro, very good integration. It's very great for very big files, but I'm not going to talk about that embedded schema concept. No. It has its use, definitely. And for Cryo, I love the speed, I love the simplicity of it, but it's not evolvable, and it's definitely not for persisting. So don't put your Cryo serialized files anywhere on disk, because you might not be able to read them later. So, and one last word of warning, which also comes from the Protobuf issue and why they change, is that the required notion. You remember, usually if you're not having worked with that too much, requiring certain things feels very natural. Like a person has a name, or if you're living in the 1970s, you would think a person has a gender, and if or maybe if you're living in 2017, you think a person has an email address, but then comes the DSGVO and the data protection officer comes to you and says, no. So things might not be as required as you think they would be. And that leads you into all sorts of trouble, and you lose a lot of the flexibility that such a framework will give you. And then a couple of relevant links that I want to share with you. First one, Effective Java, because it's just so good that you keep recommending it even if it doesn't fit at all. And then the second one, which I think is the best book released in 2017. Or maybe the best book in the last 5 years. It's Designing Data-Intensive Applications from Martin Kleppmann, which everything I said in this talk is just a tiny chapter of the book. And there's so much more in there for distributed systems, for data-intensive application. It's a wonderful book, and I can really, really recommend it to read it, even if it's not talking about programming languages, but a more high-level concepts. And there's a smaller, more digestible blog post from him about schema evolution in Avro, protocol buffers, and Thrift that helped me a lot building this talk. So I owe this person a lot. If I ever see him, I will thank him. So now that we're closing down the talk, my Twitter is Chris Uhl. Example slides and everything else you can find on my GitHub. So you see the sample code there, and then there's a folder called slides where you see the slides, and there's a folder called PDF where you can find the PDF version of that talk. So it's all accessible. And if you like listen to me ranting about things, I have a German podcast about my new role, and where I'm even more ranting about crazy stuff. Oh, and that concludes it. Thank you very much for wow, so many awake people. Thank you very much. I think we have time for one little question. So trying to repeat the question, it's about how do you nest objects or build more complex data structures, and how do you deal with that? Well, the first thing is don't. Depending on what you're going to do, right? If you're communicating between systems, you probably want to be precise, because the messages you send around are somewhat also your API. And the more complex your structures are, the more trouble you will have dealing with your API. If you need fast serialization of very complex objects, then, like I told you, Cryo is probably a way to go. But also Protobuf and Thrift have support for nested data structures. And I have no practical experience how far you can do that. Like it's there, but I cannot tell you how far to go and when it will break. Please. Okay, so the question is, when does it start or stop to make sense to include the schema in the Avro message versus not including it in Protobuf and Thrift? Just trying for the record. I did not do any scientific approach from the bottom. I would say if it's really messages, like telling somebody something, then I would rather go for the smaller things and having simple data structures that are small and easy to digest. But if you store big blobs of information to work on, like not just payload, but workload, kind of like what these big data systems do, like a workload that you will crunch on later, or kind of roughly if it gets in the megabytes or like multi-digit megabytes, then I would start thinking about it. But it depends so much on what you do with these messages that it's hard to answer.